Hey everyone, welcome to another video. Today we are going to learn a very interesting and useful algorithm. It has many names, but mainly we call it union find algorithm. It can be called union by rank, path compression, or disjoint set. This algorithm will play a very interesting and important role for solving coding problems. To simplify this problem, we will recall a very popular movie. It's called Finding Nemo. In this movie, Nemo's dad, Merlin, searches the whole ocean to find Nemo. Now let's suppose the opposite of that movie would be Finding Dad, where Nemo tries to find his dad, Merlin. Union finding is a similar sort of algorithm. We think of every element as a node and add them to its parent. We basically find their parent. Let's get into a real scenario and discuss our algorithm. In this box, you can see there are many balls. Blue balls, green balls, yellow balls, and purple balls. We want to group them. So, from here you can see they can be grouped like this. Union is a synonym of group. So we can split them into 4 unions or groups. Here, suppose the balls are all of the same color, but they are marked from 0 to 6. We want to distinct even and odd groups. So our final result will look like this. As union find algorithm is a graph algorithm, we can visualize our even and odd groups into a tree. It doesn't matter whether 4 connects with 0 or 6. The root is what differentiates between unions. Also, the root can be any of the union. It's just a representative of that union. So, for the odd union, the representative is 1, and for the even union, the representative is 0. The algorithm has 2 important functions. We will first talk about the union function. Suppose we wish to union 1 and 5 because both are odd numbers. Anyone can be a parent of anyone. So we add 1 as a parent of 5. We could also add 5 as a parent of 1, but for the case of first coming 1, so we add 1 as a parent of 5. It doesn't matter how's the ordering. Now we want to union 1 and 3. We simply add 1 as the parent of 3. This way we can actually form a union. Now that we have discussed the union method, we will now be focusing on the find method. As you can see, this method states that we will be finding the representative of a node. Representative means root or the main parent of the node. Remember our 2 groups from before? Suppose we wish to find 4. So our algorithm will look into its parent and keep looking until it finds the root. Then it returns it. In this case, we wish to find 6. So 6 will look for his parent 2, 2 will look for his parent 0, and 0 will look for his parent but will find pointing it to itself. Always the root will point to itself. So how can we find the root? Parent of root will always be itself. Okay. So finally, our find method will return 0 as the representative of 6. Now suppose we want to union 3 and 2. We can see that they are already in 2 separate groups. Union will combine them into one group. Inside union, we will use the find function to find the representative of 3 and 2. After finding them, we will be adding 3 as 2's parent. Okay, here you can see we have added the parent of 2, the second node's parent as the parent of first node. Okay, so we have added first node's parent or first node's representative as a parent of second node. Okay, second node is 2. So our final tree will look like this. We could have also added 2 as 3's parent. That would also be okay, as I said before. Now suppose we wish to visualize using arrays. In most of the cases, the input will be given in array structure. So we need to clarify and understand this. We first constructed the parent array where each element points to itself. You can see it from here. 0, these are the index. Suppose these are the index, and 0 is pointing to 0, 1 is pointing to 1, 2 is pointing to 2, 3 is pointing to 3, and so on. So we want to union 1 and 3. So 1 will be the parent of 3. We update the array where parent of 3 becomes 1. Okay, but in the tree structure or graphically we can see it can look like this, but as we are maintaining an array, we can see that the array index of 3, node 3, updates its parent. Now we want to union 3 and 5. We update the parent of 5 to the parent of 3. Here we can see that parent of 5 will be 5. Parent of 3 will return its root parent 1. We can see it from the array. Now parent of 5 will be 1. So we update the parent array where parent of 5, in this case element in index 5 becomes 1. You can see from here. Here's the pseudocode collected from Wikipedia. The code is very easy to construct. We will be implementing this algorithm in our later videos where I will elaborate some lead code problem solutions. You can see here the implementation of find method and the union method. It's very straightforward. You can implement it in C, C++ or Java, Python, any language. It's very easy to reconstruct. That's it for today. I hope you like this video. Please give a thumbs up if you really like this video. This helps the channel a lot. Also, if you like my video, feel free to share. Sharing knowledge is caring for others. Thank you.